Welcome to Explore, Explain, Highlights. In this Highlights package, we'll be looking at Season 5, Episode 9, with our guest, Alan Smith, discussing their project, the Financial Times Money Machine.
And what I liked about Philips's original kind of design for the device was that really you would just get students down to the front of the class from the lecture theatre and say, right, you be the Bank of England governor, and you be the chancellor, and you run the economy. And so, like, you know, it struck me that there was always scope to revisit this thing and kind of tell its story, if you see what I mean.
But tell its story also in the context of unlock it for more people to experience and to take part in and to enjoy. Now, again, perhaps for the audio listeners, the way that you've described this and the way that we'll show the footage later is basically a physical Sankey diagram.
Yes.
It's about flows, it's about entry points, it's about things joined together, but obviously in a physical environment it uses gravity, it uses liquid, it uses sluices. Is that the correct terminology?
Sluices and weirs. And it also uses a pump. So it isn't electronic, but there is an electric pump, which in the first version, Philips got from an old, it was Army RAF surplus. It was an electric pump from a Lancaster bomber, I think, that pumps this water around the economy. And yeah, it's exactly that. So what this machine does is it pumps water around this machine. And there are all sorts of interactive checkpoints on it that allow you to change where and how the money is routed. So you change tax rates and adjust consumption rates and change imports and exports. And all of the time, it's instantly recalibrating how the economy is functioning according to your inputs. I mean, as a data viz enthusiast as well, it's just pure gold. The machine itself has got two plotters on the top of it, which in real time traces out time series charts of, what's happening to national income, what's happening to imports and exports, what's happening to interest rates. And I'm looking at this all the time thinking, this was 1949. This is just absolutely, no one had ever seen anything like this, particularly. And what Philips had written about this, which I think is very interesting for students of data viz, was at the time electronic computing was in its infancy and it did not have a graphical method. It's amazing to us to think of a time when computers didn't have a graphical method associated with them. But at the time we're talking about sort of punch cards and very primitive kind of outputs from electronic computing, whereas Philips wrote in his write-up of this project, he's aware of electronic computing, but this allowed him to see, it was really important, he said, from a learning perspective, to see the whole system in one view. The FT's job is to explain the connected economy, right? Like that. That's kind of one of the reasons why readers. So it felt to me like somewhere in here there was going to be a very FT project to tease out, but kind of thinking about where to even start with that was difficult. And I guess one of the things that really was the starting point for that was Bob Hazlitt in my team. Turns out independently was also a big fan of the original Philips machine. He was very, very excited and interested in doing something that would allow us to create a digital version of it. And I remember we had a conversation where at one point Bob said, well, I've been thinking about getting into D3 and, doing a bit of coding. Because Bob's background was originally in sort of technical illustration and so on and kind of art, but he's a very strong visual journalist of all sorts. Really, he's a great data viz person as well. But Bob said, I'm thinking that I could do something in D3. We could have a go at creating it. And I remember thinking, well, for your first coding project, Bob, this would be quite the ask.
You've skipped past Hello World.
Exactly that. And and at that time, Bob went off to Cambridge University to see the restored version there. He spoke to the engineer at Cambridge, Alan McRobie, explained what he was attempting to do. I think Alan had heard that sort of talk before. People were sort of saying, I would love to do a digital version of this. How's that actually going to work? But Bob sort of really got his head around understanding how the machine was actually working. What was it doing? And to do that, you've got to get your head around the basic economic model at the heart of this machine, which is something called the ISLM model. And amazingly, as we can see, Bob got a basic version of this working, right? And I say basic because it wasn't really. It was working in principle. You know, you could switch it on, it would start flowing particles around the system. You could adjust all of the sliders that are present on the original machine, and you can see you get this little readout and kind of display. So we were sort of semi-excited at this time. Well, quite excited because welcome to the world of coding, Bob. Like, you can do amazing things with
Project
code.
1 complete.
So this is great. And at the time, I remember talking to Tim Harford, who's the undercover economist at the FT. He writes a regular spot in the FT Weekend magazine. And I remember talking to Tim about this machine and said, hey, Tim, you know, we're attempting this digital version of the Moniac. Are you interested in working with us on, if we can get this working, you know, do something with it? And he was tremendously enthusiastic. He'd written about Philips before, was a massive fan of what the machine was trying to do, all that sort of stuff. And so this is like 2016, back into 2016, I think. And we were kind of had got to this point, and then it stalled for one very obvious reason, which was this machine is 7 foot tall. Right? I mean, it's if you when you go to see it this afternoon, you'll get this sense of, oh my gosh, this is a beast of a machine. It's a really the physicality of it as well when it's actually under operation is amazing. Not just what it looks like, but what it sounds like.
You describe the sound as something that is a real part of the texture of it.
This water, when this pump kicks in, you get to see it, and there's some magic associated with it. Like when you switch the original machine off, you can hear all of the water drain away out of the economy, and everyone was just, you know, when we were in Cambridge listening to this, I was part of the project. It was just magic, absolutely magic. And so the thing that killed it for us really was, you know, most of the FT audience is now accessing our content on 3-4 inch screens. And it felt to me like we couldn't do justice to the experience of the original machine. Even if you could somehow shoehorn in the interactive elements into this space, it would be incredibly difficult to create something that did justice to what Philips was trying to do.
But were you not tempted to think, let's just completely revamp this?
I think there was one direction we could have taken it, and I think it probably would have been the wrong thing to do given where we were. And I mean, I think one of the things that was really great about this project is we obviously already had Bob's, like, it was great to, as part of the pitch, say this thing could work as a digital experience. But also the connection that Bob had made at Cambridge University, Professor Alan McRobie, who's not a professor of economics, he's a professor of engineering, who's structural engineering. I mean, I think he was involved in fixing the wobbly Millennium Bridge here, right? Like he's a structural engineer who was fascinated by this machine that he'd seen in the economics department at Cambridge because of just how ingeniously Philips had solved all the hydraulics challenges to replicate an economy. And so he restored that machine and was massive. He's been demonstrating it for 20 years. And he's a massive fan of Philips and the machine. So the moment we went back to him and said, we really think we can do this now, a lot of it was dependent on him saying, all right, you know, you can come along and, you know, take measurements from the original machine, understand more about how it works, all that sort of stuff. And so because Alan was so accommodating, it made it a natural thing to just celebrate the original machine and to try and capture as much of that in as detail as possible. And also, I would have sold it to myself, I think, if it had been just, here's the original machine and you can play with it. But the other thing that was really important is that I was still seeing people write about why this machine, although the underlying economic model is no longer the sort of the model that you would be using to do this sort of thing, the way that it visualizes and explains the basic flow of money around the economy, something called the circular flow of income, is still on the A-level syllabus. And so I had this sort of sense that actually, you know what, we could make this kind of proper historically faithful working and still make it relevant and contextual to today's A-level students. Right? So that would be a good thing, because we've got a very active schools network at the FT, teachers who write lesson plans around FT materials. And so we sense checked with them, if we build this machine and we put the circular flow of income into it as a lesson, would that be interesting? And they were like, yes, you know, that would be really good. And then also the other thing, just going back to your point about why not rebuild the whole thing, is we kind of thought, well, in doing that, we would learn more about how to create complex systems and visualizations like this, so that you could start to use it in the future to do other stuff, more sophisticated economic models.
Plus, you always need constraints to a degree. what you described earlier. So the one that we're going to see in the Science Museum is to a degree not sanitised, but it's clean. It's unused to a certain degree.
Yeah.
This has been used. It's got the bumps and bruises.
This is battle worn. If
Yeah.
you look at it, there's like cracks in some of the perspex. There's lime scale everywhere. It's like been used all over the time. Alan McCroby said it stopped working during the pandemic. It sprang some leaks that they had to come back and fix and all this sort of stuff. So actually, that was another thing for us, is that in terms of historical preservation, these machines are quite fragile.
Yes.
There's no guarantee that the three working now are always going to be working.
True,
so
yeah.
capturing this in a sort of a longer life version, I think, is really important.
Like an archival benefit, yeah. So we've got the original, we've got your motivation for it, we've got the gathering of the information. So how did the next step proceed in terms of turning this into a thing? Because again, this is new technology in terms of the output, but I guess the underlying 3D modelling and simulating environments is not itself new.
Yeah.
But it's developing, I guess.
Make the machine so that it's running as faithfully as possible to the original, and then you can construct some lesson plans around it to explain what's going on. So in the app right now, there's like an onboarding lesson, and then there's one lesson about this circular flow of income I mentioned. So I wrote those materials while Wong Doody were finessing what was happening on the Vision Pro side of things. And at the same time, also, I was working with the FT's magazine editors, because we'd pitched this to say, we've got something really interesting.
Yeah.
I'd kept in touch with Tim Harford. He agreed to write the historical backstory of Philips and the machine and how that all came to play. I said, we'll get Tim to do the historical stuff. I'll write a piece about the digital reworking of it. We'll make it a compelling package, and we'll make it front page of the magazine the same weekend that we put the app available for free download in the Vision Pro store. And amazingly, like trying to herd kittens, that all actually worked really, really nicely.
And there's things like there's elections taking place and there's budgets taking place in the background. The day job is still a thing. But,
it is, but it was great, because actually all of that was relatively painless, because almost like we'd done all of the hard work in researching the original. You know, I'm not going to say the piece wrote itself. It didn't, but it just flowed, just like the water in the machine. The whole thing flowed. And so, in September, we published it into the App Store. We published the magazine piece. We've made it free to read, actually, which for us was really important, to try and spin the sort of educational benefit of having this machine and what extended reality or spatial computing could do for that. We've had lots of discussions with Apple all along the way. They've been very interested to see this piece develop, because they see education and experiential learning like this, that you can just pull things and see what happens. They see that as a really big selling point of having this kind of spatial computing platform. So all of that was tremendously positive. It's also prepped me for some very unusual things, because like you say, it's our first extended reality app that we've published. And I remember talking with some people at the FT, said, right, well, of course, you're going to be the support for it. So, like, if anyone has any questions about it, it's coming to you, right? And I was like, well, okay, but what possible questions could they have?
Weekend helpline sort of guy.
My favourite one is, I mentioned earlier that one of the things about Apple Vision Pro that's really interesting in how we built the app is it's got automatic plane detection on it, so it can detect flat surfaces, which is great, because that means basically when you're running the app, you can just look at the floor and look around and then just say, right, I want it here, and it'll drop in. The first support request I had was from somebody in California who had accidentally attached it upside down to his ceiling in his condo. And it was so far away up on the roof of it that the user interface was too small for him to reset it to come back down again. And so I've got this lovely screenshot that he sent me of this 75-year-old analog water computer stuck upside down to the ceiling of his condo in California. And I felt, our work is done.
Yes.
This is the problem that I wanted. Because of course what was happening is he was looking at the ceiling, and the plane detection detected there's a flat surface there, and it kind of pinged to it, which was easy enough to resolve once I stepped him through it. But it made me realise this is no longer your typical IT support desk call, because everything's changed a little bit with it.
Thank you for joining us for this Explore Explain highlights episode. As always, the full episode is available on YouTube or wherever you get your podcast. We hope to see you again soon. on another episode of Explore, Explain.